Hi everyone. We are continuing lesson 2.1 from Algebra 2A, and this section of the notes in this video will focus on function notation, which is what you're seeing right here with example 4. So just to remind you, function notation is actually really easy to wrap your head around. Sometimes it catches people off guard when you're just reading it in context and you don't understand what it's saying, but it's really easy to work with mathematically. So this right here, this notation, the f with the x in parentheses, that's the symbol for a function. And we pronounce this as f of x. And what throws people off sometimes is you've been conditioned to learn that anytime you see parentheses like that, it means multiplication, but not when we're talking about functions, okay? So this is really, and that f really stands for function. So this is function of x. Now, I'm going to draw your attention back to something that you should have jotted down at the beginning of the notes. There was a sentence where we said the dependent variable is a function of the independent variable. If I throw in our commonly used dependent and independent variable, that's going to look like this. Y is a function of x. Okay, that's how we talk about functions. This is us saying an x value is being paired up with a y value. This is independent, this is dependent. So if I were to take this statement right here and turn it into math language, I would get something that looks like this. Y is, in math, is typically an equal sign, and then function of x is what we just talked about. So when I talk about this f of x, what I'm really saying is what y value matches up with this value of x, okay? So when I ask you to find f of 5, what that question is really saying is what y value, or what dependent variable value, pairs up with x equals 5. And in the case of an equation, really what that means is to take that 5 and plug it into the equation and find the y value. Okay, that's what this question is asking, is what y value pairs up with whatever's inside those parentheses there. If you're looking at a graph or something like that, you would go to where the x-axis is equal to 5, and then read up on the graph, you would find the y value that goes along with it. But one way or another, this is what you're trying to find. You know your x value, and you're trying to find the y value. That's what this is asking. Okay, so we've got this function down here now. They used h instead of f. Don't let that throw you off. I'm sure that's fine. And so when I ask you this, when I say h of negative 2, what I really want to know is what y value, or what does this function pair up with negative 2? Negative 2 matches up with what value? Okay, so really what I'm doing here is I'm plugging negative 2 in for x. And the question I get all the time is, do I also put it over here? Well, sure you can, because then watch what's going to happen is if I put it over there, I'll get h of negative 2 equals negative 2 squared minus 1 over negative 2. And then all we're saying is h of negative 2 equals whatever this thing is. Okay, so you can write it out over there, but this is really the part of the equation that I actually care about, is just plugging that negative 2 in and finding the value so that I can say, oh, that equals something. Okay, let's talk about how to put this one in your calculator, because this is a good review of some calculator skills here. First of all, I'm squaring a negative number, and you'll notice that I wrote it in parentheses. I really think it's in your best interest to just get used to always putting negative numbers in parentheses, especially when you're raising them to powers. But here it's going to be extra important. In your calculator, you must put that negative 2 in parentheses before you square it. Otherwise, you will get the wrong answer. Okay? And then minus 1 divided by negative 2, and I end up with 4.5. So what that tells me is in this function, negative 2 would be paired up with 4.5. That's the pairing that happens in this function. I could write that as an ordered pair. Okay? I could also just say h of negative 2 equals 4.5. So let's talk about that next one. That next one gives me h of 4m. We're going to follow the exact same pattern. We're really just taking this 4m and putting it in place of x. And then we really should simplify a little bit. In this one, the only thing that you really can simplify is this thing. If I do 4m to the power of 2 in parentheses like that, and you do need the parentheses there, remember that you're going to square the 4 and square the m. So I would call that 16m squared. And then this part, really, there's no simplifying that can happen, so I would just leave it like this. And I can't combine those two things because they're not like terms. So that would be my answer right here. Okay, these next two are on here just to kind of point out the difference here and make sure you understand, how function notation kind of operates. Here I have h of 2 plus h of 3, and here I have h of 2 plus 3. These two things are different from each other. You can't take them apart or put them together and have them come out to be the same thing. This one is saying take 2, plug it into the function, get the answer. Take 3, plug it into the function, get the answer. And then take those two answers and add them together. This one is saying take the 2 and the 3, add it together first, and then plug that into the function and get the answer. Okay? So there's a difference. So for this one, I would first want to find h of 2 would be 2 squared minus 1 over 2. I'm just going to do that in my head. That's 4 minus 1/2, so that's 3.5. Then I'm going to do h of 3, which is 3 squared minus 1/3. Let's see, 9 minus 1/3 would really be 8 and 2/3. I really don't like mixed numbers in algebra. So I would not write your answer here as 8 and 2/3. If you were to put it in your calculator, you would get 8.6 repeating, which is a fine answer for me as long as you make it a repeating decimal. If you were to make it a fraction, like an improper fraction, and I hate that they're called improper because in algebra that's what we prefer better, it would be, let's see, I think 26 over 3, sorry. So I would take either one of those answers. I would not really like to see 8 and 2/3. That being said, I would probably have a hard time marking you wrong for it. And then our last step here is to add these two things together. And if you're not feeling brave and you want to bust out your calculator for this, that's okay. These decimals are going to add together kind of weird anyway. So just make sure here, when you're putting 8.6 repeating in your calculator, you may actually want to go back and calculate it. So let me show you what I mean. Sorry, stumbling all over myself here. Even though I did that in my head, I'm going to do it here in my calculator so that I have that value already entered. If I try to enter that by hand, I have to make sure that I do a ton of sixes to imply that it's a repeating decimal. I wouldn't just want to put in 8.6. What would be even better is to use the 26 over 3, but that took a little bit of mental math on my part, so I don't know that you would have gone there on your own without a calculator. So I'm going to take that and I'm going to add the 3.5, okay? And so my final answer here would be 12.16 repeating, just the sixes repeating there, okay? So with this question, what is this really asking us for? This is really the same thing as me saying h of 5, right? Notice this one was not really h of 5. It was h of 2 and h of 3 separately. Here for h of 5, I'm going to go 5 squared minus 1 over 5. All right, and instead of treating you to my mental math process here, we'll just break down and use the calculator. And I get 24.8 here. So as you can see, the answers came out drastically different from one another, okay? So these two pieces of notation are saying two completely different things. That's the important thing to take away there. Okay, that's it for this set of notes. If you managed your way through that, you should be good to go to start your homework.